Hello everybody, this is Biswajoy Chatterjee, Vice Chancellor, University of Engineering and Management, UEM Jaipur. And as you can see on screen, my topic for today is something called golden ratio. So if you look at it, golden ratio, have a look at the screen. What is it? I start with some numbers. What do you see on screen? 1 appears. The next number will appear 1. And what is the next number? 2. So see, the first number that appears was 1, the second number was 1, the third number was 2. The next number that appears on screen is 3. The next number that appears on screen is 5. The next number which appears on screen is 8. The next number is 13. Can somebody immediately think in your mind what is the next number that will come? Yes, you're correct. 21. How do you come over here? See, any number that you are thinking of is the sum of the previous two numbers. If you look at it, 2 is the sum of the previous two numbers, 1 and 1. 3 is the sum of the previous two numbers, 1 and 2. 5 is the sum of the previous two numbers, 2 and 3. 8 is the sum of previous two numbers, 3 and 5. And so the list continues. 13 is the sum of the previous two numbers, 5 and 8. 21, the next number, is the sum of the previous two numbers, 8 and 13. So what will be the next number that will come on screen? Is 13 plus 21, that is 34. And herein is the list. The list is 1, 1, 2, 3, 5, 8, 13, 21, 34. We call it a series. The next number is 55 because 21 plus 34 makes it 55. If you continue, 34 plus 55 will make it the next number, 89. As you can see on screen over here, 89. So the next number is 55 plus 89, 144. This is a series. 144, 89 and 144 is 233. 144 and 233 makes it 377. Any two numbers added together gives you the next number. So the next number is 610. Why? 233 plus 377 makes it 610. And the next number is 377 plus 610 makes it 987. And so on. This is a series. Dot, 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 dot. This is a series of numbers, a very special series. And what do we call this special series? We call it Fibonacci series. A series where sum of two numbers forms the next number. Sum of any two numbers forms the next number in the series. That is Fibonacci series. The series itself is magical. There are many magics in this Fibonacci series. However, my topic over here is not Fibonacci series. So I get rid of it. My topic over here is golden ratio. This is golden ratio. Golden ratio is magical. There are so many magics associated with it. And what are the magics of golden ratio? That is what I will discuss over here. Have a look at this. These two numbers were 1 and 1. So 1, this one, the second one, divide it by the first one. 1 by 1. What do you get? You get 1. This is 2 divided by the previous number 1. So 2 by 1 is 2. Next, what will you do? The next number is 3 divided by the previous number, that is 3 to be divided by 2. What is it? 1.5. Have a look at the quotients. The quotients are 1, 2, 1.5. They are not close. However, 5 divided by 3, the next division is this number 5 to be divided by the previous number 3. 5 divided by 3, what is it? Taking up to 4 places of decimals, it is 1.6667. Is not so? So take the next number 8 to be divided by 5. 8 divided by 5 is 1.6. See, the numbers, the quotients suddenly got very close. 1.6667 The next one is 1.6. Have a look at the next. 13 divided by 8. 13 divided by 8, 1.625, very close. At least up to 1 places of decimals, they have absolutely matched. 21 divided by 13, 1.6153. It is getting closer and closer. 34 divided by 21, 1.6190. It is getting closer, closer and closer and closer. 55 divided by 34, 1.6176, even closer. Then 89, this is 89 divided by the previous number 55. So 89 by 55, 1.6182, closer and closer. Next, 144 divided by 89. This is 144 divided by 89. What is it? 1.618. Even closer. Now have a look. 233 by 144 absolutely matches. Up to 3 places of decimals, if you check, it is same 1.618. 377 by 233, 1.618. 610 by 377, 1.618. 987 by 610 up to 3 places, 1.618. Does not it itself sound a bit magical? Somehow the ratios have become absolutely same. One number divided by the previous number, almost the same. Almost the same. Or in fact, you can say up to 3 places of decimals, absolutely same. This itself sounds a bit magical. But this number 1.618 is given the special name. What is the special name given to it? Golden ratio. 1.618 is called the golden ratio. Now, what is the magic of golden ratio? Suddenly comes on the picture is a special picture. Is not it so? Suddenly comes on picture is a special picture. I turn off my webcam, it's not needed. This special picture is the picture of, yes, you all know, it's Mona Lisa. The famous picture of Mona Lisa. What is special about it? See, I have marked the height, I have marked the width. Height divided by width comes to 1.618. What was it? The golden ratio. It says that the golden ratio somehow or the other exists in different forms in nature. Somehow or the other it exists in different forms in nature. Somehow it has been found. Like the Mona Lisa picture, a beautiful thing, it has been divided. If you divide the height by width, it comes to 1.618, the golden ratio. In all beautiful things in nature, it says this golden ratio somehow tends to exist. Extract all the colors from this picture of Mona Lisa. There are so many colors you can see in this picture of Mona Lisa. Extract those colors and you know that all the colors have got certain frequency or the other. So arrange those colors, the extracted colors from the picture. If you arrange those colors in ascending order of frequency, you will find that one frequency divided by the previous one approximates the golden ratio. The colors, you arrange them in ascending order of frequency. One frequency divided by the previous frequency approximates the golden ratio. Somehow the colors are in golden ratio. Amazing. What do you see? Some notes of music. Again, a beautiful thing. Music is a beautiful thing. And when we talk about notes of music, we talk about sa re ga ma pa dha ni sa. Is not it so? Now extract the frequencies of this music one by one. The frequencies of the music, you know. Divide one frequency by the previous frequency. Divide the frequency of this by the previous one. You know all sounds have got frequency. So divide the frequency of this by the previous one. Divide the frequency of this one by the previous one. Divide the frequency of this one by the previous one. What will you find? They approximate the golden ratio. Frequency of one node of music by the previous frequency, divide, it will approximate the golden ratio. Amazing. Golden ratio finds himself in different forms in nature, especially in the beautiful things. Credit card, what a wonderful looking object. Credit card. Divide its width by its height. What do I mean? This is the width and this is the height. Divide the width by height, it approximates the golden ratio. It's a beautiful looking thing and it associates itself with money, and you divide its width by height, it approximates the golden ratio. Rose, the most beautiful flower on earth. Extract all the colors of the red colors of rose, and arrange those colors in increasing orders of frequency. Again, you know that every color has got a frequency. So arrange all the red colors of this of this rose in arranging in ascending orders of frequency. One frequency divided by the previous frequency approximates the golden ratio. Ratio of one frequency by the previous one approximates the golden ratio. Rainbow, again a wonderful thing. What are the 7 colors? Vibgyor, violet, indigo, blue, green, yellow, orange, and red. Vibgyor. Violet, extract its frequency. Indigo, extract its frequency. Blue, extract its frequency. Green, yellow, orange, red, extract the frequencies and arrange them in ascending order of frequency. One frequency divided by the previous frequency approximates the golden ratio. Again, all beautiful things in nature, somehow or the other, golden ratio finds its presence. Mathematics is existent in nature. Mathematics is existent in nature. And I can say you, why will you ever avoid mathematics then? So keep on loving mathematics, keep on learning mathematics. Happy learning. Thank you so much. From Biswajoy Chatterjee, Vice Chancellor, University of Engineering and Management, UEM Jaipur. Thank you.